Hello, my fellow mathematician. Welcome to the study of second order differential equation. We are supposed to solve this one. We are given second derivative of y with respect to x minus 4. First derivative of y with respect to x plus 4. Y is equal to 0. So that is what we are given. So our solution, we expect our solution to be of this form. Y is equal to c1 exponential m1x plus c2x exponential m1x, which can be written as exponential m1x into bracket c1 plus c2x. So in order for us to get the solution of this form, we are going to let our y be equal to exponential mx. Then from there we get our y prime, which will give you m exponential mx. Then we get our y double prime, that is second derivative, which will give us m squared exponential mx. Then you can call all this equation 2. So you substitute 2 in 1. Our equation 1 is up there. So we substitute. Where you have y double prime, you substitute it with m squared exponential m2. So we shall have m squared exponential mx minus 4m exponential mx plus 4 exponential mx is equal to 0. After substituting, we can call this 3. From 3, we can factor exponential mx because it is common, to be left with m squared minus 4m plus 4. This is equal to 0. Now this equation, we can call this equation 4. Now from equation 4, exponential mx cannot be equal to 0. So that tells you that whatever is in the bracket, it is the one which is equal to 0. So it means that m squared minus 4m plus 4 is the one which is equal to 0. This is a quadratic equation whereby the sum is -4 and the product is 4. So we seek two numbers, which when we multiply we get 4, and when we add we get -4. These numbers are -2 and -2. Then we come and factorize our quadratic equation here. So you will have m squared minus 2m plus 4 is equal to 0. You factor m from the first two to be left with the m minus 2. In the last two, you factor 2m minus 2, which is equal to 0. So this tells you that your m minus 2 bracket m minus 2 is equal to 0. So clearly you can see that m minus, or here you can write m minus 2 squared is equal to 0. So which means that our m minus 2 is equal to 0, and also the other one, m minus 2 is equal to 0, meaning that m1 is equal to m2, which is equal to 2. So that means that our solution will be given by the following: y is equal to c1 exponential 2x plus c2x exponential 2x, which can be written as exponential 2x into bracket c1 plus c2x. So that is the solution for our given ODE. If you're interested, you can always check whether your working is correct by doing the following. So your y prime will be given by 2 c1 exponential 2x plus c2 exponential 2x. This is a product rule, plus 2c2x exponential 2x. Then you get y double prime, which will give you 4c1 exponential 2x plus 2c2 exponential 2x plus 2c2 exponential 2x plus 4c2x exponential 2x. This one can be simplified. So you have 4, you shall have 4 c1 exponential 2x, c2, they are there, so you have plus 4 c2 exponential 2x plus 4 c2x exponential 2x. Now, then you substitute this. Our given ODE is y double prime minus 4y prime plus 4y is equal to 0. So we substitute and see whether we are going to get our values as 0. So you have 4 c1 exponential 2x plus 4 c2 exponential 2x plus 4 c2 x exponential 2x. The other part you multiply by negative 4, which is here, that of y single prime. Our y single prime is this one here. So you shall have negative 4 times 2 will give you negative 8 c1 exponential 2x. Then you have negative 4 c2, negative 4 c2 exponential 2x. Then you have negative 8 c2x exponential 2x plus the last part is c1, that is 4c1 after multiplying exponential 2x plus 4 c2 exponential, that is x there, 2x. This will be equal to, so let us check. You have 4 c1 plus 4, that is 8 c1 minus, so that one is taken and that one to give us 8, then minus this 8 here, which will give us 0. Then we come to the value with 4c2, so we have this one 4c2 plus this other one, which is 4c2 minus 4c2, which will give you, so this and that will give you 0. Then we come to this to 4 c2x plus this, which will give you 8, minus this other value here, which gives you 8. So we can see our value is equal to 0. So thanks so much for taking your time to study with me. For more such examples, tune in to my YouTube channel so that we may continue learning together.